Speak very loud already. I think you need to up the volume.
Say a bit louder.
I think you need to up the volume.
I already up the volume already.
Oh, okay.
Okay, now it's better. Okay, let us make a start. Kinematics. Let's just review what we have learned last week. All right, we define basically just a summary lah. V can stand for velocity, depending on the context of the question. I can stand for speed. If it's velocity, then x will be displacement. If it's speed, then it will be distance. So we define it as, you can write the formula, but you have to explain in the exam what does delta x and delta t means. Right? Change in displacement over change in time. Okay, so if you displacement time graph, always remember when you divide x time graph, then is gradient. Velocity is the gradient. Then we define acceleration as a change in velocity over change in time. So also the same thing, velocity time graph. Velocity time graph is the gradient. And the other thing that we, right, gradient, and this is your delta V. This is the time taken for the change. So if we go to the first formula, we cross multiply, then our delta x equals to V times delta t. So VT graph, right, is velocity against time graph. The area under the graph is a change in displacement. Okay, so afterwards, when you have a break, while you're waiting for 15 minutes, you can try this question. Who is your math teacher?
Maths.
Ah,
Miss Wong.
oh, very strict. Check on your good.
Yeah.
Okay, so try this question. As I say, physics like maths. You want to do well, you have to apply what you will learn. And by doing question, you apply what you have learned. Okay, so delta x is just your area under the velocity time graph. Okay, let's just review. I think it's about page 62 there. Right, displacement time graph. Change in the x is change in display, delta x is change in displacement, delta t is a time interval or change in time. What type of motion is this graph? Yep.
Linear motion.
Usually we say uniform velocity rather than linear motion. Yeah, correct.
Okay.
Linear motion, but more specific, uniform velocity, because it's a straight line passing through origin. What does the gradient represent?
Velocity.
Velocity, good. Determine the velocity of the moving object. Can?
20.
Okay, draw a big triangle to reduce random error. Then write the coordinate there if it's in the exam. All right, 20. Sketch the velocity time graph. How does the velocity time graph look like?
Is it uniform
So
velocity?
how does the graph look like?
Straight line.
Horizontal
Straight
line.
horizontal.
Horizontal line. So you got velocity time graph. What does the area under the graph represent?
Displacement.
That's all. Good. Let me just make a correction. I don't know why my student never. This one. Number 9. Okay. This is correct. Accelerating. The magnitude of acceleration increases because the slope increases. Whereas this one is wrong. Not decelerating. Decelerating means the speed decreases, but the speed is still increasing. Decreasing acceleration, the slope decreases. Right? Make a correction there.
Okay.
Okay, what? Say the type of motion given by the graph.
Accelerating.
You must be more precise. Uniform acceleration. Right? Example, dropping a ball. Lah. What does the gradient represent?
Well, acceleration.
That's how you find your acceleration. What is the acceleration? What's the
10
method?
meters second.
Okay, draw a triangle, big triangle, write the coordinate.
Oh, by the way, what's the area represent under the graph?
We will go into that. We will go into that in a while. I'm just having problem with disturbance of the okay, so it's 10 meter per second square. That's the acceleration. What does the area under the graph represent?
Is it displacement?
Say again.
Displacement.
Okay, good. Displacement, correct. That's the area of triangle. That's found for you already. Right? If you are asked to draw the displacement time graph, if you don't know how it looks like, then you can sketch, work it out. A bit longer, but that's how you do it. So complete the table. You complete the one done for you already. Right? This is the area under the graph for 1 second. For 1 second is half 10 times 1. So it's 5. Then the second one, second. Right? This is a triangle. Right? So it's half 20 5 times 2. So it's 20. And the third one, third second, triangle. Half, this one is 30, height is 30, base is 3. So 30, use calculator, or 90 divided by 2 is 45. Then you plot your graph. Right? But you must recognize that usually they don't ask you to plot the graph. Just roughly sketch. I know how a parabola looks like. Right? So this is uniform acceleration. How would you, if you are given this graph, how will you determine the velocity at 2 seconds?
Draw a tangent.
Okay, good. Tangent to the curve. Then you have to supposed to determine it just touching it, that's all. Roughly equal angle there, this angle and this angle roughly the same, that's all. So in this case, right? Delta x over delta t 60 minus 0, 4 minus 1 is 20. Okay, any comment? Okay, if not, we'll
Yeah,
carry
okay.
on. We'll carry on deriving the formula. As I say, try the question afterwards. Okay, this is number 13. How are the formula obtained? You need to know how to derive. Right? This formula is for uniform acceleration. A is acceleration, V is the final velocity, U is the initial velocity, T is the time taken for the change from U to V. Right? Cross multiply, take A across there. So you have V and take U across to the other side. You got U plus 80. That's our first formula. Then compare the equation of a straight line. U is our C in y-intercept. A is our gradient. T is our variable, which is our x. Then we can draw the line. As a straight line.
Mm.
Right? It must be able to interpret initial starting point, final velocity, and time t. So acceleration is the gradient of the velocity time graph. What does this area represent? What does
Displacement.
this area represent?
Displacement.
Okay, good. So it's area of trapezium. Let me just try to get rid of the problem. So this should be able to find the area of the trapezium, right? Which is half U plus V times T, right? That's your U, that's your V. We add a 2, take half of it, times your time. That's the area of trapezium. So these two equations, you are expected to know how it's derived lah. Usually they won't ask you to derive it lah. You use these two equations to obtain the other two lah. Right? Stop me if you need any comment or any clarification.
Understand.
Define velocity and acceleration. Right? That you have to memorize the definition have to memorize. These are usually 1 or 2 marks usually 1 mark lah. Velocity is the change of displacement over time. Acceleration is the change of velocity over time. Right? That's our definition. Okay, use the definition in A, which is done before. To deduce this, we have deduced for you already, this equation. Now we are going to derive this equation. Right? So this is the equation that we derive. We have derived these two equations. So here we don't want t, don't want time. Now you can do any way you like, but this is one way of doing it. Right? You don't want t, this one I got t. So we, from equation 1 or equation 2, you can work with equation 2 first. Find out t, cross multiply, take u plus v down, take the 2 across there, it becomes 2s u plus v. And place that t there inside the equation 1. Okay, place inside there, then multiply by u plus v to get rid of that. So u plus v, uv, or vu, v square, that's what we get. Then u square, u times v, and then this one cancel off with u plus v. We got 2as. Right? V plus u plus v cancel off. So we get our equation. Anything not clear?
Yeah, clear.
Okay, let's go to the next equation. Right, same. These two equations. Derive this equation. S equals to ut plus half at squared. Right? Here, we don't want v. No v in the equation. We don't want v. So we can replace that v with this v. Right? That's what we get. Half u replace the v. V is u plus at. Then we take we add this one is 2u. 2ut plus half at squared. Take the t inside. Then expand it completely. Half and 2 cancel off. You got ut. Then this is half at squared. Right? You can use your own way. Doesn't have to follow my way, you know, but remember that you know how to derive the equation. Anything that is you want to ask question, anything you are not clear?
Yeah.
Okay, let's carry on then. An object move from rest with an acceleration of 8 meters per second square for 3 seconds. Find the instantaneous velocity at 3 seconds. Instantaneous velocity is just the velocity, the final velocity at 3 seconds. So in such an equation, usually you write down what is given.
From refs.
At rest is u equals 0. Acceleration is 8. Time is 3 seconds. You want to find v. Instantaneous velocity is the final velocity at 3 seconds. Then you choose the equation. V equals u plus at. Right? U is 0. A is 3. A is 8. B is 3. So it's 24 meters per second. You can try to calculate the distance traveled in this time. Or you can use this one. They allow you error carry forward. Or you can use this one.
But I forgot the distance formula.
Say again. You
I
can use any
forgot the distance
formula.
formula.
You can use any formula. There are 4 formulas for you to choose. You want to find this distance or displacement is the same thing. I use this one. I use the value that's given to find S. That's why I choose this formula. That doesn't matter what formula you use, as long as you can get the answer. U is 0, T is 3, half, A is 8, T square is 3 square. To simplify that, 36 meters. Average velocity over 3 seconds. Right? You just take your half u plus v is 12. Right? That is the symbol for average. When we say average, we are meaning if you travel the same distance, the same time, you use the same velocity throughout. That's all. So area of that rectangle equals the area of the triangle. That's what we are doing. Okay with that?
Okay.
Okay, have a look at this question. Give you a minute or two to do the question. Then I will give you the answer.
Is the question inside the
It's in the note that I sent you. Page about 64 there, I think. somewhere there lah, somewhere page 64 after that, number 15. Try to download it lah. And
Oh, yeah, I have it already.
I will send you the past year paper lah. You can try from 2008 onwards lah. 2013, I think. No choice one lah. You have to try question on. If not, you don't know how to apply.
This one, the acceleration is G, right?
Acceleration is G.
Is it?
Yeah, acceleration is G, correct? Right? Remember, it's a vector equation. So the first thing is to take upwards as positive. The choice is basically we want positive value lah. We want negative value. That's why we choose upwards as positive. Then write down what is given. Right? Initial velocity 20, upwards is positive. Maximum height velocity is 0. Acceleration is minus downwards. So it's minus 9.81 meter s minus 2. And we want to find s, which is the height. Then use the equation v squared equals u squared plus 2as. Put in your value. Final velocity is 0. Initial velocity is 20. 2a is your g, 9.81 minus and s, and simplify 20.4. Okay, what equation do we use to find the time to reach maximum height? Right, we want to find time. So based on this is given, you can use this one. As I said, nothing wrong. The examiner allow you to carry error, carry forward. Doesn't penalize you. So if you use that, you want to find time, then you use this equation. Right? V is 0, U is 20, minus 9.81, which is your acceleration. T, you get 2.04 seconds.
Sorry, I need to see that again.
Okay.
Okay, can already.
Right? Time of flight, that means the time is in the air. It's 2 times the time to reach maximum height. It means the time it go up because the time to come down. That, remember, we are not interested in air resistance at the moment. No air resistance. Velocity of the ball at 3.5 seconds. What formula to use?
Wait, sorry, can I ask a question? Why is negative 9.81? Is it because it's upwards?
The acceleration is going downwards. We take upwards as positive always. So it's downwards is negative. Can.
Oh, so 9.81 is always negative one.
Not necessary. Depend on your choice. If I choose downwards as positive, then 9.8 becomes positive. So in a question is your choice. Right? That's why you will see sometimes I use upwards as positive, sometimes I use downwards as positive. For the simple reason I want to work with positive and get positive answer. One negative answer. Okay, how will you solve D? What formula to use?
Oh, you mean C, is it?
C we have done already. 2 times 2.04. which is double that, so it's 4.08 seconds. Normally answer is two significant figure only lah, because of 3.5 seconds lah. So how will you solve D? Any suggestion? I'll say U is given, A is given, time is given. So what formula to use?
V square equals U square plus 2AS.
No, S is not given.
Hey. Oh yeah.
U is given, A is given, V is given. Sorry, your time is given. You want to find V. V is what you want to find. That's
Oh.
U is 20. U is 20. A is minus 9.81. Put in your value, then calculate out. You get a negative answer. So negative answers tell us that the velocity is downwards. It's 14.3 meter per second downwards. That means it's coming down now lah. Okay with that?
Yeah, I haven't memorized the formula yet.
Okay. Formula you have to memorize lah. If not, you will be at a disadvantage lah. And one way to memorize is to do the question lah.
Okay.
That's why I give you a lot of questions to try out, to force it in lah. That's why maths, most of you can do very well because you do every day. So physics is like maths. You have to practice, and rather than memorize, practice, and you keep on using the formula, it becomes part of you. Okay, what is the answer for E? The final velocity of the ball before it hits the ground. Ken?
Final velocity.
Final velocity of the ball before it hits the ground.
Does that mean the acceleration is 0?
No, acceleration never goes to 0. Acceleration is always
Oh.
9.81. It's always downwards. Okay, we will be stopping in 10 minutes time in case we got cut off. Let me just review with you. Right, this one. You throw out 20, it comes down at the same height, right? Where you reach the head, it's also 20, but it must have a negative sign there. Or you have to say it's 20 meter per second downwards. So,
Oh.
right? Whatever goes up, come down is the same. If there is no air resistance. Okay?
So we have to find the velocity and just put a negative sign.
No need to find one. You are given 20 where you throw it up. So it come down must be 20 downwards. So. Okay or not? No need to calculate. Just testing whether you understand the problem or not.
Oh.
Sketch the
So
displacement.
initial
Okay, yeah.
initial velocity equals to final velocity.
Not equal. Initial
Negative.
speed equals to final speed. If it's velocity, initial going 20 going upwards, final is 20 going downwards.
Okay.
That's the difference. Speed is the same. Okay, sketch the displacement time graph and velocity time graph. How does the graph look like?
This one is a parabola, is it?
Displacement time graph is a parabola. Yeah, right. Velocity time graph.
Also parabola.
No. Right. The first one, when you are asked to sketch, is to know that you want S and T. Displacement time graph lah. S is the displacement, T is the time. And then what is given is 20 going up. Acceleration is good. Minus 9.81 going down. Right? We use the formula. And then from the formula, we can take our, instead of 9.81 sketch, usually we are not very particular. If you know it looks like, draw it. If not, you have to put in value. Lo. So in this case, you can use 10 here. This will be 5. Lo. Then you can solve the equation. Then that is how it looks like, parabola. Okay, it's just like throwing up a ball. That's all. Okay, that's sketching your graph. No need to have any value. Right? Just like you kick a ball, lo, except this is time lo, rather than distance. Yeah, remember, it's parabola. Okay, our velocity time graph, we want V against T. So to know how it looks like, that's a formula. A is given, U is given. We want V and T. So it's put in the value, then you know roughly. Since you have calculated the value, then you should be able to put the value in. If not, just sketch the graph. Lo. It's a straight line with negative slope. Right? These are all the values that we have calculated.
Oh,
So 20 initial, final is minus 20. Can anything not clear?
because the last one was negative velocity.
Acceleration is negative.
Means velocity at
Throughout
a
we use
different
the
direction.
same. We use the same. Right? Taking upwards as positive, so acceleration is downwards, so it's negative. Can? If you can memorize it easier lah. How does the graph look like lah? Right?
Okay.
When you throw out a ball, the displacement time graph is a parabola. The velocity time graph is a straight line with negative slope. Okay, we won't bother about all that. Right? In case we got cut off, our time almost up. Okay. Explain why a body moving with constant speed in a circular path accelerates. Right? Velocity is a vector quantity. That's the main thing you need to remember. As the direction changes, there is a change in velocity. Right? Remember, during the 15 minutes, wait, try to do the question that I've given you earlier.
Which one?
Circle in your paper there, this number. 7,
Okay.
8, 11, 12, 18, 19, 20. Okay, okay or not?
Okay.
I'm carrying on, okay. Our time will be
Then
good.
later we discuss.
If you want me to discuss, we can discuss, no problem. But if you can do it, no need to discuss. Okay. So remember, when it moves in a circular path or in a curve, the body accelerates if the speed is constant. Remember that velocity is a vector quantity. As the direction changes, there is a change in velocity. As long as there's a change in velocity, whether it's magnitude or direction, accelerate. Acceleration is the rate of change in velocity. Right? That's how we explain. That's the A2 work lah, where you can show circular motion. Okay. Measuring G, that you need to know also. What's the problem of measuring G by yourself using stopwatch and ball bearing? Dropping a ball from a certain height, reaction time, error is 0.2. Error in height is usually negligible because you can take 1 meter. For example, the height is 1 meter. That's the error. Right? Smallest graduation usually is about 0.5 seconds and reaction time is 0.2. That's very large error. So if you use this equation, S equals ut plus half at squared, right? You're dropping a ball, so you take downwards as positive. Lo. That's why we get our u is 0. Then you got half gt squared. Lo. They want to find g, take the 2 across there. We got 2h divided by t squared. So you multiply that, we get our acceleration. Okay. Right, usually we won't bother about this one because it's too small, less than 1%. That's the formula that we derived just now. Right? A and percentage error in G equals to percentage error in H plus 2 times percentage error in T. Okay, put in your value. Right? This one is negligible. So it's 2, that's your 2. Right? That's delta T over T times 100. So it's very high, 80%. And when we calculate out, 80% is 0.8 times 8, you get 6.4. So usually we have to round off to one significant figure only. So this is very high. Right? 8 plus minus 6, very high. Right? So we don't want this, we cannot use this method to determine G. Right? We can use simple pendulum method. We won't go into much detail.